Hello, I'm pleased to present my attempt at an Arduino Smart wardrobe prototype that combines light and temperature sensing features to make it easier for you to choose the right clothes from your wardrobe. Let's start by introducing the user persona, Mark. Mark is a 22-year-old college student majoring in computer science. He is a laid-back, easygoing guy who values comfort over fashion. Mark is usually busy with his studies and often neglects to organize his wardrobe. His motivation is to simplify his morning routine. Mark wants to be able to effortlessly find what he should wear. Next, let's take a look at the user flow diagram. This diagram illustrates how the prototype will interact with Mark and the environment. When the wardrobe door is open, the light sensor adjusts the yellow light on or off according to the brightness it receives, and the temperature sensor lights up in different colors according to the temperature it sends, prompting Mark to choose between a jacket and short sleeves. In defining the scope of the problem, my goal was to develop a prototype for a wardrobe function that adjusts the light strip according to the light, preventing people from searching for clothes in dark environments and promoting a sustainable lifestyle. By integrating temperature sensing in the wardrobe, it can help people better manage what they wear and thus improve their quality of life. I went through a comprehensive process from defining features to testing. I started by defining the desired features and functionality, moved on to prototyping, implementing hardware and software, and finally testing the performance of the model. It was a journey of innovation and increased usability. To ensure that the prototype better matches the needs and expectations of the target users, I use Nielsen's usability heuristics for evaluation and reflection. My model successfully adapts the lighting and colors to the current environment to meet system state visibility. In addition, the design provides automatic interaction between light and temperature, reducing the need for human intervention. However, it leaves room for improvement in terms of error prevention and handling, user control, and freedom. At a later stage, I will consider adding some sound feedback to prevent system failures and also give some control to the user, such as manually adjusting the brightness or color of the light to meet personal preferences. In conclusion, this prototype proves that it's feasible to use light and temperature sensor to solve the daily challenge of choosing a clothes. Next, I will show you how it works. First, when the wardrobe door is open, the yellow light recognizes that it's bright outside, so it's off. When I cover it with my hand, it turns on. If I turn the light off, it recognizes the dark environment, so it still turns on. Next, we look at the temperature-sensitive RGB light, which is green since the room temperature is now between 20 to 25 degrees. I cover it with my hand so that the temperature is greater than 25 degrees and the light turns red. Then I put a cold beer against the temperature sensor so that the temperature is less than 20 degrees and the light turns blue. I got my roommate to test it out, and he said these features will really simplify the process of choosing clothes. It feels like the model is very responsive, but sometimes when he doesn't want to put on his coat, he would like to be able to manually control the color of the lights and switch them on or off. He thinks in the morning when he is in a hurry and sometimes may ignore the changes in the lights. So based on the user feedback, I will further refine it in future assessment.